Okay, practice test number 1. What is the IQ score of a student who has the lowest GPA? So we're going to find the student who is lower than any other, and that person would be right there. What is the IQ? 103, 104. As long as you're within 1, you'll be fine. Okay, number 2. What is the average GPA for all students? So we're looking at GPA, and we want to find the line that cuts this in half. And remember, it's by weight. It's not by number. Right? The median would be the middle point. So these items down low weigh less. They're going to sort of drag the mean down. Does that make sense? So to cut right in, well, that is one straight line. There we go. Just turn your head a little bit. So I would say that this probably cuts the points in half, but remember, this is going to have a left tail, right? It has outliers on the bottom, on the left. So it'd probably be a little bit lower than that. So between 7 and 7.5, somewhere in there. That's what I would say. Okay, number 3. For students who have an IQ between 123 and 127, what is the average GPA? So I'm going to draw a vertical line at 123 and at 127. So that is just going to have those people. I need to draw the average of those. I got 9.3. So if you're within a couple decimal points, that will be okay. 8.7, I would say, is too low. What do you think? I mean, 8.7 would hit right there. I would say that's too low. Make sure somebody writes these down because I don't have an answer sheet. I need to make one. All right. Number 4. For students who have a GPA between 5.5 and 6.5, what is the average? That should say IQ. So let's do a horizontal line at 5.5 and a horizontal line at 6.5. So that would be these kids, and the average 103. Number 5. The line drawn on the graph is the least squares regression line. Remind me what the least squares regression line does. How do we get... So it's the line that you create squares according to the y value distance. No, that was a mistake. It should say... Because he said GPA twice. Yeah, that was one thing we fixed. So yeah. I mean, it doesn't make sense. The answer would be 6 if it said GPA twice. So yeah, that was a mistake. Okay, back to number 5. There are lots of different regression lines. One of them is you draw the x distance for every point from the line, and then you move that line around until the sum of all of the x distances is the smallest that it can be. Okay? Another regression line would be to measure the y distances from the line, and then you try to minimize the y distances. But the regression line that we use takes the y values and builds a square out of them. Every point has a y distance, and we turn that y distance into a square. The reason we do that is to get rid of the negatives. And then the least squares regression line is the line that makes the sum of the areas of the squares as small as possible. And we just call it the regression line instead of saying least squares regression line. And the least squares regression line is better at predicting than any other line. Okay, it's better than the SD line. It's better than any of the other prediction lines. So use this line to predict the GPA of a student with the IQ of 110. I'm going to get a line, and I'm going to draw a vertical line at 110, and then a horizontal line. It looks like 7.5. Okay. Can we predict IQ using GPA on this line? Could I say somebody with a GPA of 6 should have an IQ of 94? Does that work? No. The regression line goes through the middle of all of the columns, and if we want to predict X on Y, then we have to go through the middle of all of the rows, and that's a different regression line. Okay? All right. What would you need to calculate in order to estimate how far the typical point is from the regression line? The RMS error, the root mean squared. Now let me remind you what the RMS error is. We know what the standard deviation is. So if we take the, what did we say the average was? 7? If we take the Y average, okay, that Y average has a range that's that big, right? How far are those points from the average? Well, it would be, if I went up 1 SD, that might be a little too big. Nope. If I go up 1 SD and down 1 SD, and I draw those lines, I would expect to capture 68%, which is 2/3, just a little more than 2/3. So the SD measures, on average, how far are the points away from 7, or whatever the average is. Does that make sense? Okay. And if I draw the average line and I go up 1 SD and down at 1 SD, I will capture 2/3 of the data. If I go up 2 SDs and down 2 SDs, I would capture 95%. Does that look about right? Nope, this is not RMS error. This is just SD. Oh, sorry. What did I change it to? Hold on a second. I don't think so. So, hang on a second. Let me double check. I don't. Okay, so looking at this, so again, the answer for number 6 is the RMS error. Uh-oh, this is not the right one either. Okay, so now I'm looking at the correct number 7. So what I have just drawn on the board is the SD. Okay, and that only includes the Y values. If we are looking at the regression line, so the Y values are pretty spread out compared to how far the points are from the regression line. So instead of looking at the SD, if we just measure how far each point is from the regression line in Y values, right, the sum of those numbers is going to be smaller than the sum of the differences from the mean, because the regression line is way closer to the points than the average line. Does that make sense? The spread around that horizontal line is larger than the spread around the regression line. Okay, so for that reason, we calculate the RMS error, which uses the least squares. You do the Y values, you square them, you take the average, you add them up, take the average, and then you take the square root, and you end up with a smaller value than the SD. So the SD tells us that there are 68% in that window. The RMS error tells us that there is 68% in that window. But that window is smaller than the horizontal window. because the regression line is closer to the points than the average line is. So if you're just looking in one dimension, if you're just looking at the y values, an average point is about 1 SD away from the mean. If you are looking at the points compared to the regression line, the points are about 1 RMS error away from the regression line. Okay? So the SD is either vertical or horizontal, and the RMS error is slanted parallel to the regression line. So number 7 says, draw the RMS error lines on the graph and estimate the RMS error. Estimate the RMS error to be just from looking at the graph. I need to fix that. So about how far do you think you need to go up and down to capture 68%? And I think I'm off-centered a little bit. I would say about there. Right? So 1.3-ish. That looks like about 2/3, right? So I would say 1.3. So I draw the lines that capture 2/3 of the data, and then I just look how far is it from here to here. So it looks like from about 2 to about 3.3. So I'm going to guess the RMS error to be 1.3. Does that make sense, Lizzie? So it's just a guess. You added them up? Oh man, don't do that. Yeah, just draw a line, draw a positive and a negative line that capture 2/3 of the data, and then measure the Y change. That's the RMS error. Okay, does everybody understand the difference between SD and RMS error? They do exactly the same thing in different circumstances. The SD compares one number to itself, right, a series of numbers to themselves, and the RMS error compares Y values to the regression line. But the 68, 95, 99.7 rule applies to both. Okay, number 8, estimate the correlation coefficient. What would you say R is for this data? Now, without those other points, that would probably be about what? 0.8. But it has to be smaller than that because we have all of these points here and this point, so maybe 0.6. And if you're within a decimal point and a half or so, that's okay. I mean, if you put 0.3, you're going to get it wrong. If you put 0.8, you're going to get it wrong. Yeah, 0.7 is pretty close. I'd probably allow that. So if we have the SD, which is, what is it, 2.4? So number 9, the SD is 2.4. I told you that. And the R value is 0.6. Let's calculate the RMS error. It would be the square root of 1 minus 0.6 squared times 2.4. So the square root of 1 minus 0.6 squared times So it's probably actually 0.5, huh? So my guess is 0.6 is too high. Or maybe 2.4 is too high.
I put 0.4. Try 0.4.
0.4 is going to go the wrong direction. It's going to make it even larger. So my guess is the SD is actually 2. Let's look. I just threw the SD up there. So if we go up 2 and down 2, yeah, that captures So my guess is the SD is actually 2. I'll change that on the future tests. So if we put a 0 there, and then we change this to a 0.6. Come on. 1.6, that's a lot closer. And as long as your math is sound, that's okay. These are all estimates, right? I just want to make sure that you can look at the graph and make estimates, right? Yes, Destiny? I had 0.6. Well, we estimated the RMS error to be 1.3. And we were getting numbers that were too high. And again, as long as your math is sound, you'll get it right. Because these are just estimates. Okay? All right, number 10, true or false? The correct prediction for an IQ test score for a GPA of 5 is about 85. So if I look at a GPA of 5, the correct prediction for an IQ score should be 85. False. You cannot predict X's using Y's. Right? The regression line only works for Y on X. It doesn't work for X on Y. So we can predict Y values. X can predict Y, but Y cannot predict X using this regression line. There is another regression line that will work, but they're not inverses of each other. So no, the answer would not be 85. In fact, the other regression line probably looks like this. It's going to hit the point of averages, but it's going to be reflected across the SD line. Do you remember that? If we take the SD line, which is this one right here, and we take our regression line and we flip it, we will end up with the other regression line. Thanks. Okay, next page. So we have Chinese women. Heights. X bar is 155. SDX is 8. And wingspan, Y bar is 158. And SDY is 6. A woman has a height of 140 centimeters. What is her percentile rank? So let me lock these. We draw. We're only dealing with one variable, right? We are only dealing with height. So we use the normal curve. We know that the average height is 155, and the woman we're looking at is 140. So I take 140 and I subtract 155. Why did I do it that way and not the other way? Because we need to end up with a negative number. Yes. So my z-score needs to be negative because I went left. So this woman is 15 centimeters shorter than the average woman. Now what? Divide that by the SD. So negative 15 divided by 8. So the z-score is negative 1.875. And we want her percentile rank. Is that the area to the right of her or the area to the left of her? Area to the left. So this area over here. The easiest way to find that would be shade norm. So I clear out my draws. And I go to zoom recall. And that will give me my normal curve graph. Maybe, when it's done. And then my distribution. So I want to shade norm from negative, a really big number, negative 5 to negative 1.875. My standard deviation is 1 and my average is 0. And I end up with 3%. So this woman is pretty short compared to everybody else. Now I just made these numbers up. So they don't really mean anything, but it does matter. Okay. 12. A woman has a wingspan of 178 centimeters. What is her percentile rank? So now my average is 158, and I want to measure a woman who is 178. So 178 minus 158 is 20. Yep, value minus average every time. And then we divide that by 6. 20 divided by 6. And I end up with 3.3 SDs. Do I need to do anything else? That has to be the 99th percentile. What we're saying is we have gone to the right 3.3 SDs. And the rule for 3 SDs is 99.7%. So we can stop and say 99. Why not 100? You never reach 100. Right? Percentile is how many people are you taller than. So if you are the 0 percentile, you are the shortest person. If you're the 98th percentile, there is one person out of 100 that's taller than you. Okay? Yeah. Okay. 13 is backwards. A woman is in the 47th percentile. Find her wingspan. So this would be the 50th percentile. Where is the 47th percentile? Just to the left. So I know that this area is 47%. The equivalent area on the other side is also 47%. So this is 6%. Does everybody understand that? Now we look at our table, and you have a printed table, which is way better than A104. 6% is 0.08. And in this case, it's negative. Good. So this score right here, Z, is equal to negative 0.08. Okay? So we know how many SDs to the left this woman is. We need to turn it back into centimeters. So we're going to multiply this by the SD, which is 6. So negative 0.08 times 6 is negative 0.48. What does that mean? Half a centimeter below 158. So 157.5. Does that make sense? And the formulas are up there on Darian's poster. Mm-hmm. Right. Yep. So z-score, and z-score times SD will change it from standard units into centimeters, and then you add the average back in, which in this case you actually do the average minus 0.48, and we get 157.5. All right. 14. A woman is in the 98th percentile for height. Find her height. So this is 50, and we want to be over here at 98, which means I have a right tail of 2 and a left tail of 2. The middle area will be 96%. So I go to my table, 96%. Yeah, I would say 2.05. It's right in between 2.04 and 2.06. So this z-score is 2.05. That's in standard units. I need to turn it back into centimeters. So I multiply by, which is 8. 2.05 times 8 is 16.4. What does that number tell me? This woman is 16.4 centimeters larger than the average. Add 155. and I get 171.4. Hey, is this all coming together finally? Okay, 15. What time do we get out of here? Okay. Should be. I don't. I don't remember. We'll just go to the bell rings. 15. Which variable has a higher percentage of measurements larger than 167? Height or wingspan, or are they the same? And we did this before. We know it's the same, but let me show you how we do it. So this is height, and this is wingspan. So I have 155 here, and I have 158 there. Okay? And we are going to go over to 167. 167. And we're going to calculate the percentile rank. And that will tell us which one has more that's larger. So actually, we want to know this, right? We are going to compare those two areas. So this one is 12. We went right 12, and we're going to divide that by 8. And I get 1 point, is that right? 5? Okay. And then this one is 9, and we're going to divide that by 6, and I get 1.5. Now at this point I can stop. I have converted both histograms into the standard normal curve, and I got z-scores that are equivalent, which means there are just as many people to the right of the height graph, of 167 in the height graph, than there are in the wingspan graph. Okay, so I could go through and calculate the area. I could do shade norm from 1.5 to 5, and then I could do shade norm from 1.5 to 5, but obviously that's going to give me the same answer. Okay, but what if this one equaled 1.4? And chances are on the test it's not going to be same. It might be. But what if this one is 1.4 and this one is 1.5? The 1.4 has more. Because if I go to the right 1.4 and I go to the right 1.5, which one has a larger area to the right? 1.4, because 1.4 is closer to 0. So you have to be very careful when you read these questions, because if it said, yeah, then you have to do some thinking. Yes. Well, you don't even need to shade norm. I guess you could. And you have to be careful, because it might say measurements lower than 167. If I said measurements lower than 167, which one wins? 1.5 would win, because it would have a higher percentile rank. So you have to be really careful when you read these questions. Are we looking at right area or left area? And actually, all you have to do is compare the z-scores. Now, if you don't understand that, do shade norm and compare the areas. I'm not allowed to let you use it. I'm sorry. It will. I'm writing the midterm, so what I did was I took the second half of the first test, and then I wrote 3 of every question basically. So it won't be that long. You'll get it done in a class period, easy. The test will be about 1/3 as big as this. It's one of each type, basically. And I mean, a couple of them will have 2, yeah. Okay, number 16. To change centimeters to feet, we need to multiply the number of centimeters by that number. If we change all of the women's height into feet, what happens to the average and the SD? So if I take my centimeters, so 155, and then I have my SD of 8, if I convert to feet by timesing by 0.03, Is the SD going to change? Yeah, it's going to change according to that number. So, hold on just a second. Hold on, this is important. If I multiply all of the values by 0.03, then the SD will be multiplied by 0.03 and the average too. But, listen to this. What if I subtract 10 centimeters from every person? Does the average change? Yes. Does the SD change? No.